Right, page 169, question number 62, similar triangles. We're dealing with similar triangles. Now I can see that these two are similar. They have two angles the same, and therefore this angle will be 180 minus those two, and so will that one. So in fact all three angles are the same. So these two are similar triangles. This big one is an enlargement of the small one. The side lengths have been enlarged, but the angles stay the same. So I'm going to treat this like an enlargement problem. I can see that this side here has been enlarged to this one. 16 has been enlarged to 24, so if we work out how many times bigger that is, 24 divided by 16 is 1.5. So the big triangle is 1.5 times bigger than the small triangle. So that means if we try this side, 20 times 1.5, x is going to equal, it should be 30, or in millimetres. And clearly y has been multiplied by 1.5 to get 15, so to work out y, we'd have to do the reverse operation, the opposite. 15 divided by 1.5, which gives me 10 millimetres. Right, over here, we're having a look. We're told there's the double angle, those two. There's a single angle represented, and a coloured in shaded angle. Now we need to find the two sides that correspond that both have measurements on. Here's the double single side, and here's the double single side over here, so they've both got numbers on them. So this side here, there's a double angle and a single angle. Double angle, single angle. So those two sides are the same side on each triangle. Now, working out how many times bigger that is, 20 divided by 16, 1.25, 1 1/4 times bigger. So the big triangle is 1 1/4 times bigger than the small one. So taking this side, which is between the double angle and the shaded, the 24 must correspond to this side, being the side between the double angle and the shaded, that's z. So z will equal 24 times 1 1/4. Quarter of 24 is 6, add that on, 30, and we're in metres this time. So lastly, the W must correspond to the 25 side. We'll check W is between the shaded and the single angle. Shaded and single, yep. So to work out W, I've times it by 1 1/4 to get 25. So to work out W, we'll do the reverse. We'll do the opposite. 25 divided by 1.25, which is probably about 20. And that's in metres as well. So just quickly, the same sort of question. We need to identify two sides, and I think this side here between the shaded and the single, and this one between the shaded and the single, they must correspond. So if we try and find how many times bigger the second one is, 31 divided by 72, 9/8, 1.125 times bigger. All the lengths on this second triangle are 1.125 times bigger. So that means this side here between the dark and the light one, dark and light, corresponds to this side, the K and the 36. So to find K, 36 times 1.125 times bigger, 40.5 millimetres. Right, and lastly, this side between the lightly shaded and the single, lightly shaded and the single, so J corresponds to this side. So we've multiplied by 1.125 to get that number. So working backwards, j will equal 54 divided by. Once again, that probably works out nicely to 48 millimeters. Right, same thing over here. We need to find two sides where we know both pieces. Single and shaded, single and shaded. So here we go. The side between the shaded and the single. This one is the side between the shaded and the single. 30 divided by 25, 6/5. 1.2 times bigger, the second triangle. So all these lengths are 1.2 times bigger than the small one. So that means this here, between the double and the single corresponds to P. So to find P, we're going to go 20 times 1.2, which will work out nicely to be 24 meters. And clearly here's the shaded and the double angle, shaded and double. So Q has been multiplied by 1.2 to give me 32. So to find Q, we're going to divide it by 1.2, which probably works out nicely again, not quite so nicely this time. 26.7 meters, we'll round that to one decimal place.